Right? So as we stated yesterday, if you're graphing, the boundary line will be dashed if it's greater than or less than. The boundary line will be solid if it is greater than or equal to or less than or equal to. And then if y is less than or equal to, you shade below. If y is greater than or equal to, you shade above. And then you can choose a test point in either side and determine if it is true or false. Okay? So in example number 1, we have y is greater than 3/2 x plus 1. So in the case of this problem, we have greater than, so my shading will be above, and my line will be dashed. So without even doing anything, I'm thinking above and dashed. I'm going to start with my y-intercept, which is positive 1. I'm going to apply my slope of up 3 over 2, or down 3, and left 2. And again, my line is dashed. And my shading is above. In example number 2, my y value is not isolated. So in order to do the above, the dashed, etc., you would want to isolate your y. So I'd subtract over 4x and then divide by 2. So I get that y is less than or equal to negative 2x plus 2. So my y-intercept is at 2. My slope is negative. My line is solid because it's less than or equal to. And y is less than, so where are my y values less than? Well, that will be below the line. So I shade below the equation. Okay, in example 3, my graph goes through the origin. My slope is 3. My line is solid. And I am shading above. You can pick a test point at any time. So I could pick a test point, maybe I pick -2, +2. So what that means is I plug in -2 for x and +2 for y. And I get that 2 is greater than or equal to -6. Since that test point is true, where I shaded and the test point should be the same, which they are, so we're happy. If I were to pick a test point outside of the shading, then I would hope that my test point comes back false. So if you picked 2, 0, I get 0 is greater than or equal to 6. That's false. Well, I want it to be false because my test point is not where I shaded. So once again, I am happy with that solution. Okay, and then in number 4, we need to solve for y again. So I have x thirds subtracted by 2 less than negative y. So again, you can't leave the negative on the y, so you divide both sides by -1. When we divide by a negative, it changes the direction of the inequality. Now again, the y is on the right, so the shading above or below does not work. They only work just like if the variable's on the left. So you have to have y is less than negative x thirds plus 2. So in order to follow the shading above or below, the y value has to be on the left side of the equation. Instead of dividing by -1, you could have also, which I think some of us might have done, which is totally fine as well, you could have added your y to the other side and then subtracted your x. And what you'll see is you still get the same thing. Now you just don't have to worry so much about the y being on the wrong side or rearranging your terms. Yes? No. So if you multiplied everything by 3, that would give you 3y. Oops. And that wouldn't make this your slope then. And that wouldn't be your y-intercept because you have the 3 on the y. If I divided everything by 3, I'd get right back to that. Do you see what I'm saying? Yes.
So negative x over 3, is that the same thing as negative 1/3 x?
Yes. Yep. So my y-intercept is 2. And yes, you could rewrite it almost like this. That's your slope. So then that means I go down 1 and over 3, or up 1 and left 3. This is less than, so it's dashed and below. So an application or a word problem aspect to this problem is, here's a restaurant. They have so many eggs. They have 2 types of meals that use the eggs. And you want to know how many of each type of meal you can create. So the restaurant has 15 eggs. An order of scrambled eggs requires 2 eggs. So maybe we say that variable s represents, represents scrambled. And an omelet requires 3. So O can represent omelet. Write an inequality to model all possible combinations of orders of scrambled eggs and omelets. So if you need 2 eggs per scrambled, that's 2s. You need 3 eggs for omelets, that's 3o. And the total number of eggs is 15. So the orders of omelets and egg with omelets and scrambled eggs has to be less than or equal to 15. So we'll say that S is kind of like my X and omelet is like my Y. So if I make all scrambled eggs, so we'll find our quote-unquote S-intercept and my O-intercept, which are like your X and Y-intercepts. So the S-intercept occurs when you make no omelets. So that's 2S plus 0 less than or equal to 15. So S has to be less than or equal to 7.5. And then my O-intercept is if I make no scrambled. So that's 5 omelets. So what that means is any combination of omelets and scrambled eggs that fall below this line can be created that day. So I could make 6 sets of scrambled eggs and no omelets. I could do 3 scrambled and 2 omelets. I could do 2 scrambled and 3 omelets, and so on and so forth. I cannot make 4 omelets though. Or, sorry, 6 omelets. Because it is outside my region. Does that make sense? We have 35 performers in a circus. Some are in cars, some are on bicycles. Each car holds 7 performers. Each bicycle holds 5. Draw a graph showing all combination of cars and bicycles in the possible finale. So I have B bicycles and C cars. So there are 7 performers per car, plus 5 performers per bike, and my total performers are 35. So if I have all bikes and no cars, then I could have 7 bicycles. If I have all cars and no bicycles, then I could have 5 cars. And again, I could have any combination less than that. So then the word problem continues on and says, find the minimum number of bicycles that would be needed if 3 cars are available. So if I have 3 cars available, Now I sort of have another boundary line going in here. So if I have 3 cars available, now my solution region is the overlap of that red and that blue, but not the little blue by itself. So if you have C equaling 3, you have 7 times 3 plus 5B less than or equal to 35. So that's 21. 35 minus 21 would leave 14 performers divided by 5, and you get 2.8. So what that means is the minimum number of bicycles that would be needed, or the maximum number of performers you could use, is 2.8. You cannot do more because you don't have enough. And then it says determine 3 other possible combinations of bikes and cars. So you could pick any combination of points in here as long as they were below or in our shading. So you could do 1 car, and 5 bikes, 2 cars and 4, 3 cars and 2, etc. Okay. And then the last part of the lesson is kind of taking everything we've done but in reverse. So if I give you the lines and I give you the shading, can you write me the equation? So you would identify the y-intercept, determine your slope, and then look at if the graph is solid or dashed and shaded above or below. So we're shaded below, so y would be less than. My graph line is solid, so it's equals to. My slope is going down 1 and over 2, so negative 1/2. And my y-intercept is at positive 3. In number 12, you have an absolute value. We're going to graph absolute values and shade them tomorrow. But at this point, you should already know how to write your equation. My graph is open up. My slope is positive 1. My vertex is at negative 4, negative 3. So that's y. It's shaded below, so it's less than. The line is solid, so it's equal to. And then it's your absolute value of x plus 4 minus 3. Because it's simply your vertex and the slope. You have a solid line with a slope of positive 2. Shading is above. And your y-intercept is at 5. It is greater than or equal to because the line is solid. Slope goes up 2 over 1 for the 2x. In 14, my line is dashed but shaded above. I have a y-intercept at -2, and my slope appears to go down 2 and over 3. Okay? So your homework is that next page. Again, I have you graphing 6 of them and doing 2 word problems. So nothing crazy. Make sure for the word problems you label your axes like we did. So like tell me which one is which. So you have math and English as 2 of the categories on 7. Just make sure I know which one's math, which one's English. Because, you know, your neighbor might flip-flop them. And you'll still get the same answers. You just might have a slightly varying slope or graph.